Welcome back to the 2020 Capital City Classic. We will be discussing collaborative online design using Onshape with our two speakers, Ben Pochop and Alex Berghart, and me, the moderator, Juan M.
Good afternoon, everybody. My name is... Oh, sorry, Juan. Go ahead.
So first up, we have our first poll, which is which CAD software has your team used the most or in your last build season? And so we would like to direct you to Mentimeter and just follow the directions at the top of the screen.
While we're waiting on those poll results, I'm just going to go ahead and introduce myself and give Alex a chance to introduce himself as well. My name is Ben Pochop. I am one of the mentors for Team 701, and we're here today, like Juan mentioned, to talk about using Onshape for collaborative online design. With me is Alex Berghart, our design head. Alex, say hi.
Hello.
And so once these polls get rolling, we'll get started here in just a minute.
So far, we have Onshape, SolidWorks, AutoCAD 2001. So far I'm seeing a lot of SolidWorks and some Fusion 360, but for the most part, it's mostly SolidWorks, Onshape, and Fusion 360 that's coming in a lot. And there's a few others like AutoCAD and Autodesk, but the biggest ones seem to be SolidWorks, Onshape, and Fusion 360. Today we'll be mostly talking about Onshape and collaborative design in there.
Awesome. So that's good. SolidWorks and Onshape are very similar. In fact, they were created by the people who made Onshape used to work at SolidWorks. So a lot of those features that you're used to are going to carry over and be the same for those of you who are there. We still use Fusion 360 on 701 for portions of our projects, and we'll talk about that a little bit later in the presentation. Let's go ahead and hit the next slide, Juan.
So the next poll question we have is whether or not your team is able to work in the same building currently. I think that it's really important because we're currently in a pandemic to know, like, if you're working fully inside with your team or it's remote or partial.
Yeah, and we're in the same boat here. So it looks like most of the people who have responded, we are not allowed in our shop at all. I'm here streaming from the shop today because that's the quietest place I could find, but I'm not allowed to have any students on campus with me. And so one of the things we want to talk about today is how you can maintain your momentum, keep doing work, continue building and iterating on your design aspects, working with your robot, even though you can't get to your shop where you have your CAD computers or you have your server set up for your part sharing and all those things. We're going to talk through how Onshape allows you to continue with your trainings, keep your rookies engaged and onboard them, and as well keep your upperclassmen involved and working through design challenges, even though they may not have access to the same hardware they would if you were in the shop. I think that's all the responses we're going to get here. So we skipped a couple slides, it looks like. Yeah, back one more. There we go. So again, we're going to talk here today, and we're going to start off with that high-level 50,000-foot view. I think I saw one response that said your team was currently using Onshape, so this will be a little bit of a recap for you. But for everyone else who was coming from SolidWorks or Fusion or AutoCAD, I'm assuming that's Inventor, you're going to see kind of what the basics are here before we get into the collaboration tools. So Onshape is a collaborative online Google Docs style tool. Onshape gets used, and you can use it hardware agnostic. This is one of my favorite features of Onshape. I have my phone, and I will regularly open up the Onshape app on my phone and check parts for my students or take a look at their designs, look at drawings, and I can do that no matter where I am or what I'm currently doing. It runs on Chromebooks. I know a lot of schools have given out Chromebooks to their students for remote learning, and this gives you the option of doing CAD even though you can't install software on a Chromebook or you can't install software on a district provided laptop. You can still access CAD through your browser. It's the Google Docs of CAD. That's my term for it that I use a lot. And there's a good and a bad side of that, right? If you're coming to Google Docs from Microsoft Word, you're going to see that there's a lot of features that are not quite in the same place or not necessarily the way that you want them to run. And you're going to get 90+% of what you want out of it, but there's still some really high level advanced stuff that's missing. And you're going to have that same problem in Onshape potentially. Now, I have not hit that issue with Onshape and FRC. We are able to do everything we want to do with it, but that is a possibility. The other part here is that it's automatically updated every 3 weeks. They release an update. So you're not waiting for the next year or next release cycle, SolidWorks 2021, 2022. Every 3 weeks, you're getting new features. Onshape is not CAM software, finite element analysis software, or rendering package. It doesn't work offline. These are some downsides to it. You are really good. It's a great parametric modeling tool. But if you want to do renders, you want to do designs, you want to, oops, sorry, clicked the wrong button there. You want to create a render of your package, do some CAM, run a finite analysis or element analysis, stress analysis, you're going to have some issues there because those aren't built into it as a feature. There is a store where you can get some add-ons that do have those capabilities, but those add-ons aren't always free. So our workaround for that is that we take our files and we do our design work in Onshape, and then anything that we need to do beyond that, our CAM, our stress analysis, or our rendering, we just drop it down into Fusion through a step file, and we're able to run those analyses that way. We're going to hit 4 kind of key topics here today about sharing and collaboration. Onshape teams, we'll talk about those a little bit. We'll also go through kind of a sample workflow that we use on 701 to give you some hints there. And then at the end, we'll talk about branching and merging, which is a little bit more advanced of a topic. If you want to follow along, I think Juan can put this into the chat. This will take you to the Onshape document or a Google Drive folder, I forget which one is which, that we are using that has the presentation and everything in it. So, Onshape, why would you want to use that for sharing and collaboration? Aside from the fact that we're in a global pandemic and 80% of you aren't able to be on in your shops right now. There's also the benefit that you have mentors that potentially get stuck working late or can't make it to a meeting for whatever reason. They're able to log in when they get a minute or a chance, and they can provide you feedback that way. You have a chance to do online training and feedback, which Alex is going to talk about here. And we'll talk a little bit at the end here about ways that you can use this when you're back on campus. 701, we've been on Onshape fully for 2 years now, and we're not going back. So Alex is going to jump into our Onshape presentation here with me, and we're going to show some demo things here. So you can see my screen here, and here is Onshape, and I can see, just like in a Google Doc, hey, look, Alex is here. Hi, Alex. And if I'm working and we're doing some things left and right, I've got my general user interface, just like any other CAD software. Those of you coming from SolidWorks, if I push the S key, I get my context menu, right? All your features, your favorite things are there. But I can also give some feedback to Alex, whether we're meeting at the same time or not. Alex is working on a part and he sends me a message and says, hey, I finished this up. Can you review it? I can leave comments directly on that part and say, hey, Alex, you might want to look at this. And not only does it show Alex that there's a comment for this part here, but it also shows him, if he clicks it, the view and highlights what I wanted to talk to him about. So that's a benefit here. Gives him a chance. You can see a comment here from last year from Tony, who was our design head of the year before. And so comments are a way for anybody to interact, get some quick feedback on small things, and you can do that at any time. We're also going to talk today about follow mode. So Alex, if you can go ahead and just start moving around and showing some different things of your screen. So I'm following Alex right now. He didn't have to do a screen share to load up to this presentation. He didn't have to do anything on his end. I can see his mouse clicks. I can follow what he's doing. And if he wanted to go ahead and edit a part here, I can see his sketch, I can see his changes as he's making them live. And so if you're doing remote training, a lot of what we've noticed, both me as a teacher and Alex doing the training for our students, when you're running Google Meet and you're running online CAD software and your students are, your team members are working on computers that are of varying quality and work power, sometimes doing a screen share just causes everything to lag and bog down. And so by doing follow mode here, you can see what they're doing and follow along, give them a hint or a help, and also allow them to show you what's going on without adding that extra strain on your hardware. Additionally, if I wanted to show Alex something specific and we're talking through, he can follow me. Go ahead and follow me, Alex. And you'll get a little notification. And I can show Alex, hey, look, no, I'm talking about this part right here. And there's no long-term effects of, okay, now rotate 40 degrees to the right and go to the back view and isometric. I can take and zoom and show him exactly what I want him to see. We also have the benefit here of multiple people editing at once. So we're going to go to this simultaneous work slide together, Alex and I. And this is a piece of 2x1 aluminum tubing. Hey, look, everybody knows what these are. And we took 1/4 inch clearance holes every inch along the top face and bottom face of our tubing, as well as a pattern here as well. And if you're working together on a part, a lot of times in other softwares, you have issues with resolving connection issues or problems like I did this and you did that and they conflict. So what we're going to show you here is Alex is working on the top. Oh, sorry, go ahead, Juan.
So how does like this help with collaboration, mostly during remote learning?
Yeah, so during remote learning, right, I can show Alex exactly what we want to do. This is a little more geared toward this particular part. You're working together on a part. Alex and I both want to make this part. We want to get it done really fast. So Alex is going to put a hole pattern across the top. I'm going to put one here on the side face. And there's no resolving issues. There's no problems going back. If I wanted to demonstrate for Alex, right, he can still see me here. He can follow along with what I'm doing, and we can make those changes together. So I'm just going to put a simple hole pattern here. And at any time, if I wanted to talk through what Alex is doing on his end, I can go look and see, hey, look, here's where he's at on his part. You're tell him his hole sized incorrectly or he has a problem there. So as you're training your rookies or you're working through a design with your other teammates, you have that option and that ability. This is, again, a very simplified example of what we're looking at here. This isn't something you would necessarily have to worry about. Obviously, creating 2 hole patterns is something that's really quick and easy to do. But you can see that when we're done here, assuming I can click the right buttons. When we're done here, Alex has his part done. Hopefully he's finishing up here in just a second. I have my part done. And we were able to do that together at the same time. There's no versioning, there's no saving our Fusion 360 files and dealing with issues with the overwriting of the correct or most recent version. I can change my part and his part independently of each other, and we can work on those at the same time. So you get this ability to collaboratively design a part together. This is stupid simple, but you can see if we're working on building a frame, Alex can work on the width portion of the frame, I can work on the length portion of the frame, and we can start putting this together really quickly together at the same time. We're also going to talk a little bit later on about branches, which you can see up here. I just want you to know that they exist at this point, and we'll come back to them at the end of the presentation. So the next thing we're going to talk about is your Onshape teams. We had a step here where we were going to do a volunteer, but that didn't work out. So Onshape teams and building a part library. And you can see right here in my share settings, I've got Team 701. Everybody in that team can edit this document. I'm not actually the owner of this document. Someone else made it and I've added to it. So I can do all these different settings and then anybody with the link can view it. So if you're working with a team from another part of the country or that's not local to you, or right now a team from anywhere because you can't interact with them one-on-one, you can share these links over and show them different things. You can give them different permissions to access your documents in different ways. 701 is our team though. And so by creating a team, I can just with one click or one button type, share that document with everyone in my team. And building a team is really simple. You just go here to teams, you create it. You can give it a description if you'd like. And once you've done that, you just add some emails and you populate that team. And now every time I share that document with the team, I can share it with everyone. So as your number of people on your team or your design team grows, it makes a lot of sense to do it this way rather than trying to share that document individually. Because if I'm just sharing with Alex, it's very easy to hit share and talk to Alex. If I am trying to share with the 30, 50 members of my team, then it makes a lot more sense to use that Teams feature. Using the Teams also gives you the ability to build out your part libraries. So right here is our library that we've built over the past year, and we're still working on this. You can see you've got your different components, right? Just like you would in any other CAD software where you've imported some step files and we've converted them into Onshape files so we can drag and drop them into our assemblies where needed. And because we set up our team and shared those folders with the teams, everybody in the team can link those documents into an assembly. I'm going to turn it over to Alex here for a couple minutes to talk about online training and what he's learned. He's been leading that aspect for our rookies.
All right. So the learning curve is just like every other CAD software. It's pretty steep if you've never used it before. Adjusting to Onshape is relatively easy for people who are already proficient with other software, though. And because it's a little more niche than some other programs, it kind of assumes that you already have some basic understanding of CAD, and so it's not really the perfect way to teach rookies. So the Learning Center is a feature that Onshape has, where it's just a bunch of videos and instructions on how to do stuff. Most lessons have videos, and it makes it easy to follow along. But as I said in the last slide, it's more geared towards reviewing, not teaching people who don't really know how to do it. So because of this, it's really important to check in with rookies to make sure that instead of just watching and reading the instructions, they're actually understanding it. And even if they do understand it, checking in is also helpful to review it and solidify it, because a lot of the things that they learn through these are the foundation of CAD.
Before we move on, Alex, did you want to show some of those training parts you've done?
Oh yeah, but I think you need to screen share.
Which one do you want to start with?
I'll start with this one. So this shaft, it's 1 inch thick instead of ½ inch, which is what we normally use. So that was because we told them to make a shaft that was ½ inch, and instead of dimensioning the opposite sides, they dimensioned it from the inside. So the way that we solved this issue is I think we used screen share for this one, and we just showed them what the correct sketch should look like, and then they fixed it for themselves. Yeah. And then the next one, this one was more difficult to explain because there were a lot of faces, and to prevent them from just copying what we were doing, we did it all the first time, and then we did it again, and then we had them do it after we had completely finished it.
Awesome. So the next step here is then, right, eventually, ideally, at some point, hopefully sooner rather than later, we're all going to get back into our shops. We're going to come back from working in our online collaborative environment to seeing people more often. So what we're going to see there is you're going to be back in your shop, and there's going to be some reasons to maybe continue on with what you've been doing before, where you're working on your Fusion or your SolidWorks, and if you're want to keep going with that, that's great. I'm going to talk through some benefits that happen or can happen now if you come back to your shop and you want to keep using Onshape. So a couple of those have to do with your production or your manufacturing team. And what happens, or what we've noticed, is that we print drawings. We print a lot of drawings. We print a lot of reprints of drawings. Drawings get hurt, drawings get torn, drawings get messed up, drawings are wrong, and they have to get rebuilt. And so what we've found is that we can use a branch in Onshape specifically for the manufacturing team, and they can see this part, right, on their phone or on a computer without hunting someone down, and they can hide aspects of it, and they can look at it and explode it out on their own to see exactly how it's supposed to go together in a 3D space, whereas a drawing is more just a two-dimensional aspect. They can get dimensions that they need. If the dimension was missing on the drawing, your designer missed that part, or it's changed, or it's been modified, they're able to see those things, and they can do all that without hunting down someone from your design team and asking them a bunch of questions. It gives them the power to find those answers on their own, which leaves your design team working on the things they want to work on. Remote collaboration, honestly, in my view, is still going to be necessary even if schools are open in the spring. We're looking at, in our district, being told that even if we're meeting on site, we're having to do reduced capacity. So our manufacturing team that runs our CNC machines and our tools, they might be allowed to be on campus because you can't do that from anywhere else. But our design team, our programming teams, they can work remotely, just like you're seeing in industry right now. And so you're still going to have some type of remote collaboration aspect you're going to have to do. Additionally, you might have a student who's sick who still wants to come in and do some work. And that's a big no-no now. You should not be coming in when you're sick. I know I've done it. I haven't felt great, but there's been important stuff to do and I've come in. And so now you can still, even if you're sick, stay home. You can log into your Onshape. You can have that remote meeting. You can work on those tools together and get those things done. We're going to finish off here today with our branching and merging before question and answer time. And branching and merging is, again, another method here to work together, to collaborate. Here's a quick pros and cons list, and this is by no means exhaustive. We're looking at just a couple examples here of some things that are good and bad. You can quickly, right, tie a bunch of ideas without having to worry about how they interact with each other by making some branches. You can, one of the things we like to do or have added in is adding a render branch. We paint our robots dark green and black, which you'll see in a minute here makes it really hard to see them in the CAD. And so by making a render branch, you can put your high quality models of your electrical components. You can put your colors of your robot in there and have that branch separate so that you can work in your two different aspects. The simplest form of branching and merging is very easy to do. Doing it at a higher level, just like if you have worked with or have heard anybody working with GitHub, the more advanced features that you're using, the harder it is to implement. And just like with GitHub, not everyone can do a pull request in GitHub for programming. You need someone who has that ability to lead and manage the merging process and deal with any potential issues that pop up. You don't want just anybody to be merging things back in. So we're going to talk through a quick branch and merge demo here. So I've got my branches here, and Alex, you're still in main?
Yeah, I'm still in main.
Okay, so Alex is still here in main, and I'm going to go to this branch that I called Fenrir No Color. Fenrir was our robot from last year. And if you look here, where's my drive base file? There it is. Here's a drive base. Here it is in main. And again, right, those dark greens, the blacks, it's kind of hard to see where those holes are, what pieces interact or where, and it looks really good, but it's not the best for usage. And so Alex, while I'm in here, can you jump into this superstructure parts and delete out this floater?
We have a question asking, what have you found are best practices for documents, studios, assemblies? Should you have lots of tabs, single tabs, or multiple links?
Yeah. We have lots of documents, lots of tabs. I can come back and I'll show you our library here just as while Alex is working on that. So our library, again, it's broken down. There's a lot of folders, and in those folders are individual documents. We have some of these that have tabs. Simple electrical board components, for example, has different tabs linked in. So that gives us the ability to kind of work in it. By having it all in different documents, you're going to run into processing slowdowns. Is not the best method. That we've seen that has kind of caused our assemblies to chug. If you have your links or your link documents and your versions, I think it was Onshape posted a update recently that said the best practice for that, you're going to see better performance.
Have you had any issues with ownership? Should all team members give ownership to the team account?
Ownership. So like people, yes, we have had issues with ownership. So here's our library again, right? And this was our design head last year, actually our director of engineering last year, Will, and he built these libraries and kind of made them. And one of the things we ran into was that students who were adding files in couldn't delete anything because of the way that the folders were set up and the permissions. They weren't able to delete anything. They were able to move things around. So we had to make this trash folder for them to move it. So there are some issues there that you can run into. We haven't had any issues of people opening the documents and people who aren't supposed to open documents opening documents. You do have that ability to change your permissions, right? Copy, link document, export. Those are the basics. You can change how those are given, who can do what. We kind of have as our general format or rule is that the robot and all the parts that go into it. Let's see if I can find. Here's Fenrir. Here's our robot from last year, and you can see these document folders get pretty hefty. A lot of different stuff going into them, and these are just shared out mainly with the whole team. We also gave it some other permissions here for anybody with the link, or these are 2 add-ins that we tried to link up to, but mainly that giving that permissions to the team lets everybody see it, manipulate it, and do what they need to. Alex, are you done?
I'm pretty sure, yeah.
I'm pretty sure you deleted that part. So you can see here, right, I'm in a different branch than Alex. I'm in the no color branch where I've taken these components and I've gotten rid of the dark green color to make it easier to see what's going on. And I didn't delete this piece. This piece is just kind of floating in space. I think it's attached to something in the final assembly, but I'm not 100% sure. If I go to Alex's branch right here, that piece is still there.
I deleted the wrong part. I gotta redo it. Okay, it's loading. It should be gone in just a second.
So that part's going to disappear here in a second. And I'm just going to show you real quick. You have your 2 branches, and I made my branch with this versions in history, and you'd create a version, and from each version you can right click and create a branch to create a new workspace. Super simple, doesn't take a lot of work to do. And what you can do is you can compare these, right? So I can look at my 2 workspaces and see what's different between the 2 of them. It'll tell me assemblies. It doesn't like to compare those. This tab doesn't exist in one versus the other. Same thing for this one. They were slightly different. It found some differences here, and if I look at those folders, it'll tell me what the differences are. In the sketch, something changed. The assembly I can't see, and then here in the superstructure, which is the file that Alex just modified, in mine, it has that floating piece, and in Alex's, it's gone. So I can compare my differences right here. And again, this is a simplified version of this. This is not necessarily the utmost ability. I just wanted to show you quickly how you can kind of compare those things. And so now that I'm here and I've seen those differences and I'm happy with what they are, I can take this and I can take my branch with no color and I can merge this back into the main branch. And when I do that, it merges my colors back in. Wait, did I do that wrong? Merge. Oh, sorry, I did that backwards. Merges my colors back in, and it gets rid of that part. So both of those changes that happened in different aspects get carried over and work back together. Now, again, simple, 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 but you can envision a place where this is a bracket for part of our climber mechanism up here. You have 3 or 4 different teams create a branch and work through some different iterations of this climber. And maybe one comes up with a really good way to connect it to the base frame. Another one comes up with a really good way to connect it up here. You can merge those changes back together and have them carry over and attach to each other, which is kind of nice. You don't have to do a bunch of assembly deletes and adds and moving things around later on. My next piece here is going back. We've kind of zoomed down and talked about a bunch of features in Onshape. We're going to go back up a little bit to a higher level, and I just want to give you an overview of how we do things on 701 for some sample stuff, and we'll talk a little bit about the things that we like and don't like about Onshape, and then we'll be question and answer time. Alex talked yesterday at the mechanical design presentation, and so if there's any kind of questions on this, he can handle those. But basically, we take our parts and we go from Onshape, where we do our collaborative work. We build those parts, we build those assemblies, we're creating those drawings in groups, we're working on those things in a collaborative way. And once they get finalized, we know this is what this part is going to look like. We can export it out through Step and take it to Fusion, where we do our cam and our rendering. This gives us the ability to, when we're done, right, we know at this stage when we're exporting our step files that we're not making changes to this part, and if we are, we're going to have to remake it anyway. So at the export step file part, it's kind of final, and we know what's going on there. Before this, we have a bunch of changes, and we want multiple people to be able to input in those changes in that Onshape section. Once we go to the export, we don't need the collaborative aspect anymore, because creating a cam file is a kind of a one-person job. Creating our rendering is a team process, but they only do things individually, one at a time. The last thing is things we like and don't like about using Onshape. So we really like the collaboration. It's great. I love it. Being able to tell someone, hey, let me log in and look at exactly what you're looking at without having to email a file back and forth feels a lot like when we're in the shop and a student asks me a question and I just go over to their computer and look over their shoulder. It's really nice. No hardware requirements, essentially. Like, you can run this on, I ran it on an 8-year-old Chromebook. I've run it on a Raspberry Pi. Granted, big assemblies start to have issues, but you can do a lot with very, very little hardware power. And the phone app is nice. More so for your mentors probably than anyone else, but the ability to see comments, chime in, add responses to quick questions, no matter what's going on, is really nice and able to be able to do. Drawings, your basic features, extruding, revolving, sweeping, all those things are the same. Assemblies are basically the same. There's not a lot of differences here in your basic kind of core functionality. And then again, that dislike that we came up with is when you're running Onshape and some video conferencing software, it does cause stuttering. It can cause some problems with your computer slowing way down, your graphics getting chunky on the Onshape side. And so it's nice to be able to do that follow mode to avoid those issues, but it is something to be aware of. Did a little bit of research in preparation for this, not an infinite amount, so this could be, there's might be some stuff missing here. But other choices, there are some other things that exist, right? SolidWorks, I believe, is working on an online version of SolidWorks, and it's in beta right now. I don't know that it's available for FRC teams or students to use, but it is something they're trying to bring online. Fusion 360, again, sort of is the same, has some differences. You have to download Fusion, you have to run it as a standalone software. You have to sync your files back and forth. So you're still kind of in that check-in, check-out mode on your software files. You're not seeing the instant updates. And that's my last slide before Q&A.
So if you have any questions, just put them in chat.
I see Jim's got a few here. We did last year successfully convince one of the rendering companies to give us, hey, I didn't know that, Robert. Good to know. Give us some rendering time on their servers to be able to use that add-in. And the students kind of did a comparative analysis on it and found that using Fusion and downloading the files and running it in Fusion was almost easier than using the online built-in add-in tool. And so we didn't end up doing that. I'm just going to go down the list here, Jim. Follow mode doesn't work when you're in a sketch. That's somewhat true. What happens is if you make a brand new sketch and you have nothing in it for the very first time, follow mode, you won't be able to see the sketch. But once that sketch has been committed and they've finished it once, and then they go back in and edit it, you'll be able to see the sketch. Parts and assemblies with respect to the origin planes. So I think I see what you're talking about, Jim, and we'll see if this, I'll come back to your origin assembly question in just a second. I don't know if the education version is worth it, honestly. I looked at it right now. Actually, I think we're past the cutoff date, but I know they were offering it as a free update for schools for a while. I don't know when that cutoff or when the date was. It was in November sometime, but the extra features that I've seen, there was a couple that I really, really liked and a couple that just didn't work for our team. The enterprise, educational enterprise version comes with, the big one that I liked was the ability to track your users. So you get a dashboard as an admin to the panel, and you can log in and see who's been spending how much time in what aspects of your robot design, which would be really helpful for seeing who's doing what, from especially if they're working from home. The other things that come from enterprise releases mainly are have to do with version product release levels. So taking things from InDesign to in manufacturing to full release and having those tags within your enterprise level for that are the other things in enterprise education. There's more, but I don't know what they are because I didn't look that closely at it because it was a lot of money for not a lot of extra functionality, in my opinion. So looking at an assembly, and let's see if I can get my screen share back up here. So I'm here, I'm in a brand new assembly, Jim, and I think I'm trying to translate your question from the chat. Hopefully this works. You want to get this to the origin planes of your part or the origin planes of your assembly. You've got your origin here and your assembly, and your front side planes are all there. And you can attach these parts in. If I just click here in this area, it automatically attaches it to the origin, and that it's going to be oriented that way. Or I can place it wherever I want. So if I go like this and I drop that slide in right there. And I can then do a fix, or a ground is the other term that's typically used in CAD for this. It's now locked origin to origin on this piece. So it's going to be laid out that way. If I want to rotate it, I have my rotations here, 90 degrees, and now it's rotated. It's off a little bit of my origin, but I can do a mate connector fastened here between the origin and that part, for example, and now it's locked on the origin and it won't move. Hopefully that answered your question. So you're looking for the mass properties here, Jim? Is that right? And you want it to be above the origin. So if you're attaching this assembly to your origin again, let's see. For example, this base rail, if I go in here and I attach this to the origin, it's going to shift that over. It's going to take a second to solve this here. Let's try that again. Origin to that piece. Oh, something's grounded. There we go. So that's origin is attached there at that point, and you want to have it with a different location, right? Respect to the carpet. You can edit these fastens with the offset, and you can move them around how you want to go. So if you wanted it to be above the origin, I could make it 12 inches above the origin. 12 inches. And now everything's shifted up by a foot. Any other questions? I am not sure on that question, Jim. Sorry. Looks like you can set your reference frame to be different things. So you could pick part of your, change what connection you wanted to have there. But yeah, I'm assuming it defaults to the origin. And just in case anybody missed it, Robert Green pointed out that Fusion 360 does now work on Chromebooks. So that's news to me. I had not seen that yet. So that's great for those of you who have Chromebooks that you need to use for your school district.
Is there any final questions? If if not, thank you and have a nice day. This is the ending of our panel.